Welcome back. In this segment, we are working on question 3, DBE 2022, that is Maths Paper 1. It's a continuation of question 2 because it is based on number patterns, sequences, and series. In the previous video that I posted, we worked on it was quadratic sequences and arithmetic sequences. So it continues on question 3. Usually there are two questions that appear in paper 1 on sequences and series, covering those three types of sequences: arithmetic, quadratic, and geometric. So this is based on geometric sequence. Now in my first video, I explained the terminology that we used when we are working with the sequences. Go and visit that video if you want to refresh and remember some of the things. So we are going to get into the question right away. So it is 3.1, okay, which reads as follows. Consider the following geometric sequence, which is 1024, then 256, then 64. Calculate 3.1.1, the 10th term of the sequence. So that one is an easy question, 2 marks. So we know that the general term for a geometric sequence is given by Tn is equal to AR to the power n minus 1. Okay, I call it the Tn formula. That's how I call it, because we use it when we are given if you are asked to calculate questions like this one, like the 10th term, or maybe you can use it to find the position of a term. So we use the Tn formula. Okay, so that is the formula that we use. Basically what it says that if you are going to find the term in any position, take the value of A being the first term of the sequence, in this case 1024, R is our common ratio, N is the position. So translating this 10th term, it means that we are going to calculate T10. Okay, so calculate T10, substitute A is the first term 1024 into R. R is our common ratio. Okay, it is T2 over T1. Okay, it is T2 over T1, or T3 divided by T2. I can just take T3 over T2. We are already given that is a geometric series, so we know that the R is going to be T3 over 256, which is T2. Okay, so we can write it like that one because we are going to enter into a calculator, which is 64 over 256. It will simplify, of course, and then with this we are raising to the n minus 1, n being the number of terms, the position of the term, which is 10, which is 10 minus 1, which is a 9. All we have to do is to work out that in a calculator. So let's punch it in a calculator. So type in what is on the right side of that equation. So that is 1024 will be 1 over 256. So our number is 1 over 256. So therefore our T10 is that. Okay, 3.1.2. The question is to calculate the sum of the terms in 256 4 to the power that. Okay, the sum of all the terms from P is equal to 0 up to 8 in the formula 256 by 4 to the power 1 minus P. Okay, 1 minus P. Now, what you do, the standard thing when you are given this, it's a sigma notation, is you are going to create a series. We know that a series is a sum of a sequence. So we are going to create a series by substituting natural numbers into our formula. So what we are going to do is to substitute when P is equal to 0, okay? So we are going to substitute here P is equal to 0, then P is equal to 1, then P is equal to 3 or 2. Natural numbers. Natural numbers are counting numbers. Okay, so we start from the term below the sigma notation, ending at the term above the sigma notation. Okay, so that will give us the series. Actually, this is an 8. Okay, that is an 8 there. So when we do that, we are going to have 2, 5, 6, 4 into 4, 1 minus 0. So let's put it that way. Now formula, I'll delete this one there. So 2, 5, 6 into by 4 to the power 1 minus 0. Okay, let's close that one down like that. So the answer will give us 10,024. So that is 10,024, 10, 10, 24 plus, okay, so you find that this one is basically the same sequence that we have been given here when P is 0. So it's the same sequence that we are given there. So now we substitute 1. So I guess when we substitute 1, we are going to get 256. Okay, let's do it here. You can verify on a calculator. What you do after you've done this one, all you need is to replay and delete the 1 and delete the 0 and put the 1 there and press the answer. You will see a 256. So the second term is 256. The third term will be 64 plus so on and so on, right? So when we have created our series, this is the sum. There are many terms that we are going to add here from 0 to 8. So we can use the sum of a geometric sequence. So in this case, we'll use the SN formula for a geometric sequence. The sum of a geometric sequence is A into 1 minus r to the power n over 1 minus r. Okay, and here, how many terms are we adding? We are adding actually 9 terms, okay, from 0 to 8. So we are looking at sum of 9 terms. The formula that you use is 8 subtract 0, that is 1. I've seen most students, they make a mistake there. They just look at the top number and they think that that is the sum of the terms that they will use. You have to take note of the number where you are starting from, the natural number that you are starting from. For example, when we are starting from -1, just as an example, so the formula that you use is you take the top number 8, subtract -1, that will give you 9, but you must add 1 more because that -1 is being counted. So here you must be careful there that our terms is 8 minus 0, okay, that is 8 plus 1. So coming back to the question, so we are adding 9 terms. So our A will be 1024 into 1 minus our ratio is again 64 over 256. I'm just using these as smaller values to the power 8 now, because that is what the formula says, to the power 9 rather, because our n is 9, that is to the power 9, okay, everything divided by 1 minus the common ratio, 64 over 256. Okay, so we just have to enter those values in our calculator. Let's enter them. So that will give us, put in your fraction there, because we are going to enter numbers on top there in the numerator. 1024 open bracket 1 minus, that is you can choose to put it in brackets, that is 64 over 256, that is raised to the power 9. Okay, and we close that, come down to 1 minus 64 over 256. That is giving us, let's try decimal. Well, let's leave it like that. 87,381, 87,000, so that will be 87,381 over 64. 87,381 over 64. Okay, that gives us the sum of the 9 terms. The first two terms of a geometric sequence are negative t squared, negative 60, negative 9, and t to the power 3 plus 9t squared plus 27t plus 27 everything divided by 2. Determine the values of t for which the sequence will converge. Now what we need to understand by that phrase here, will converge, it means that when a sequence converges, especially this happens with geometric sequences, our r is a number between 1 and negative 1. So mathematically we express it as negative r is less than or equal to, and negative 1 is less than or equal to r is less than 1. Simply put, it means that r is a number between negative 1 and 1. In other words, our r is a proper fraction. Okay, a proper fraction, is a fraction in the form a over b, where a is less than b. In other words, a is a number smaller than b. E.g., you can have 3 over 4, you can have 7 over 15. The denominator is bigger than the numerator. Like in this case here, we saw that our r is 64 over 256. That's a proper fraction. So any number, it can be positive or negative, that is between negative 1 and 1 is it's a converging series. It will give us a converging sequence or a converging series. So to work this one out, so our question is, we are given the first two terms, okay, and that we are answering 3.2. Negative t squared, negative 60, negative 9 is our first term. Then the other one is t to the power 3 plus 9t squared plus 27t plus 27 over 2. Okay. So what we need to do is to find our r. What will be our r according to this sequence? So our r is t2 over t1. Okay, second term divided by that. When we divide, we are going to get our r being equal to t to the power 3 plus 9t squared plus 27t plus 27 everything over 2. But remember, we are going to divide by that one, so we are going to get 2 by negative t squared, negative 6t, negative 9. Okay, we can simplify this, the denominator, into, I'm going to factorize a negative here, so it's going to be t to the power 3 plus 9t squared plus 27t plus 27 over, when I factor out a negative, it will give me negative 2 into t squared minus 6t plus 60 plus 9. Okay, why I'm factorizing here? Because now I'm going to factorize this, factorize the top part and the bottom part. Okay, the bottom part is easy to factorize because this is quadratic. We have got a negative 2 into that will be t plus 3 and t plus 3. Okay, numbers that we divide, that will multiply to give us 9, the 8 to give us 6. The top part is a cubic function which you can factorize by using the factor theorem. Okay, I'm going to tweak around with the formulas here by using a calculator. Okay, so on a calculator, I'll go to mod, I'll press mod, okay, mod here, right? So I've got equation under equation 5, choose 5 there, okay, and under 4, you've got 4, because we are going to solve, treat it like you are solving a cubic function, because this is a cubic function. So I'll have a 4 here, choose 4. Then we are going to enter A, B, C. A, B, C are the constants here, 1, 9, 27, and 27. So I'm going to enter 1, press equals, 9, press equals, 27, press equals, and the constant 27D is equal. Then after entering that, press equals again. It will show that x is equal to negative 3. Now, in most cases, it will show you x1, x2, x3, because with a cubic function, you will most likely have 3 roots. Okay, but now when it says x is equal to negative 3, it means that you only have one solution. So which means when we are to write our factors are going to be x plus 3. So it will be x plus 3. Remember to change that sign there. X plus 3, x plus 3. Okay. But one thing here that we are missing is, remember we are using x. This is just a general entry. Our expression in terms is in terms of t. So actually we must write it as t. So in place of x there, we must put t. We must factorize in terms of t. So we are going to have t plus 3, t plus 3, t plus 3. Okay, and then in the end, these ones, as you realize, they are going to divide and cancel. So our r, therefore, r is going to be t plus 3 over negative 2. Now coming back to our condition for converging sequences. So for a sequence to converge, we said that our r should be between negative 1 and 1. So we are going to write that condition here and say negative 1 is less than r is less than 1 for converging sequence. So therefore, since our r is this, we are going to write a substitute r with t plus 2. So when I have negative 1 less than t plus 3 over negative 2, and then less than 1. Okay, now we are going to eliminate the negative 2. We multiply by 2. So multiply by negative 2, we are going to get a 2. And remember, when you multiply by a negative number, the inequality will reverse. So negative 2 times 1, that is a 2. We are going to reverse the inequality. So it will reverse to a greater than sign. This will be a t plus 3. And we multiply this one by negative 2. We are going to reverse that one into negative 2. Okay. when we subtract 3 from both sides, so this will be 2 subtract 3 is greater than t is greater than negative 2 subtract 3. So we are going to get here negative 1 is greater than t is greater than negative 5. So actually our final answer, we can write this as negative 5 is less than t is less than negative 1. So that gives us the final answer to that. Or you can write this as t element of numbers from negative 5 up to negative 1. Okay. That brings us to the end. Thank you for watching.